Alright, so now we're looking at question 4, and the question 4 would start by saying, not saying what this is saying to clear, as the turnips pictures were taken really bad. Question 4 says, determine the first three terms of the expansion 1 minus 8x to the half power, and it's 4 marks. So we need to expand 1 minus 8x to the half power. Now all we need to remember is that 1 plus x to the n is equal to 1 plus nx plus n times n minus 1 x squared plus, I want the first three terms, so that's all it needs. So therefore 1 minus 8x to the half, 1 plus, in this case, n is a half, where x is now negative 8x, that's minus 8x, plus, this is a half, or this is all over 2, a half times n minus 1, a half minus 1 is minus a half, times negative 8x squared over 2 factorial, which is 2. So therefore, 1 minus 8x to the half, that's equal to 1. Negative 8 times half, that's minus 4x. That's 1 minus 4x. And then this is now 8 squared is 64. So that's 64x squared. This is minus a half times half is a quarter. A quarter over 2 is minus 1 over 8 times 64x squared. That works out to be 1 minus 4x minus 8x squared. That's 1 minus 8x to the half. That's it. Nice. That's 4 marks. So that's it right there. 1 minus 8x to the half is 1 minus 4x minus 8x squared. And all you have to do was remember this formula. 1 plus x to the n is 1 plus nx plus n times n minus 1 x squared over 2. Nice. Alright. The next part of the question says, by letting x equal 1 over 100, determine the square root of 23. So, remember, we just found that this is 1 minus 4x minus 8x squared. And it says put x as 1 over 100. So now let x be equal to 1 over 100. If x equal 1 over 100, this becomes 1 minus 8 over 100 to the half power equal to 1 minus 4 times 1 over 100 minus 8 times 1 over 100 squared. If this is what we have now, 1 minus 8, remember 1 by itself is 100 over 100. So 100 minus 8 is 92. This is 92 over 100. Raised to the half power is square rooted. So that's 92 over 100 square rooted equal. This is 1 minus 4 over 100 is 1 over 25. Then 1 over 100 square, that becomes 100 square is 1, 2, 100 square, 100 times 100 is 10,000. 1 times 8 is 8. Yeah? Now 4 into, let's divide it, simplify and divide through by 4. 4 into itself 2 times, 4 into this, 4 into 10, 2 times, remainder 2, that's 500. This can simplify some more, 2 into itself 1, 2 into this, 1, 2, 5, 0. So, the square root of 92 over 100, we can rewrite this as the square root of 92 over the square root of 100 equal put that part here in the calculator. Just, you don't even need to break this down any further. Just put all of this in the calculator. 8 over 10,000. We put this in our calculator. 1 minus 1 over 25 minus 8 over 10,000. And we get 1199 over 1250. This is 1199 over 1250. But the square root of 100 is 10. So this part is now just 10. So you can cross multiply, and then you have the square root of 92 is equal to 10 times this is 11990 over 1250. And the zeros then would cancel each other, so that does make it be 1199 over 125. Now the square root of 92 is the square root of 4 times the square root of 23. Now the square root of 4 is 2. The square root of 4 is 2. So from that, we end up have 2 times the square root of 23 is equal to 1199 over 125. So divide both sides by 2. I'll get therefore the square root of 23 is, because remember the square root of 92 is the square root of 4 times the square root of 23. Divide both sides by 2. 1199 divided by 125. We'll divide that by 2. We end up get, we'll divide both sides by 2, it becomes 1199 over 250, which works out to be 4.796. That's the square root of 23. 4.796. That's the answer. How much marks they give for this? Probably 4. They gave 6 marks for this. We get 6 marks. Whoa. We got 6 marks and we didn't really do anything. So that's that right here. That takes care of part A for number 4. Nice. Part C says we're supposed to use the intermediate value theorem to show that the equation 4 sine 2x plus x squared minus 3 has a root on the interval 0, 1. So 4 sine 2x plus x cubed. Is that an x cubed? Yeah, that's an x cubed. Minus 3 equals 0, and then say it has a root on 0, 1. Right? So let's call this f of x. Let f of x be equal to 4 sine 2x plus x cubed minus 3. I need to zoom in some more to see if that's x cubed. X cubed or x squared? Alright, I think it's x cubed. I'm not seeing too clear this picture. So what is x cubed? So first thing is find f of 0. F of 0 is the sine of 0 is 0 plus 0 minus 3, which is negative 3, which is less than 0. And f of 1 is equal to, put in the sign of 1 in a calculator. So put in 4 sine 2 times 1, which is 0.13, so that's 4 times. Put it in radians. By the way, anytime you're working with between 0 and 1, and it's something with trig, put your calculator in radians. Put your calculator in radians. So it's 4 times the sine of 2, which is 3.637 minus 1 cubed minus 3, which works out to be minus 1 minus 3. That's negative 0.3. Negative, oh, this should have been a plus, sorry. Plus 1 cubed. This is 4. 4 minus 3 is 1, so that's 1.637 which is greater than 0. So if you were to draw a sketch of the function, when x is 0, y value is negative 3. So when x is 0, the y value is negative 3. When x is 1, y value is 1.63. So when x is 1, the y value is 1.637. So even if it's a curve, we don't know how the curve looks, just drawing a curve. Even if it's a curve, we know say the root and then between 0 and 1. So we can therefore say by IMVT, since f of 0 is less than 0 and f of 1 is greater than 0, therefore f of x has a root on 0, 1. That's it. F of x has a root on 0, 1. That is IMVT. And how much marks are given for this? 4 marks. So this is a whole of 4 marks. That's that question right there. Nice. Now the next part says, using 3 iterations of the interval bisection, find an appropriate approximation of the root. So we're going to use bisection method to find the root. So part 1 is done and dusted. Let's just write down what we know. F of 0 is negative 3. F of 1 is 1.637. So we're going to take off here to do the bisection. So first thing we need to do is find the midpoint. So bisection number 1, the first bisection is 0 plus 1 divided by 2, that's a half. Now what is f of a half? Plug a half into this function. Please remember, put your calculator in radians. Please put a half right in here. So 4 sine 2 times a half plus a half cube minus 3. So put in a half in the calculator. 2 times a half is 1, so it's 4 sine 1 plus 1 plus a half cube minus 3. I get 0.49. 0.49, which is greater than 0. Now, since this is greater than 0, which one less than 0? The f of 0 was less than 0. So from this, we can say the root lies on 0 and a half. That was using the first bisection. Now the second bisection now is to find the midpoint of 0 and a half. So 0 plus a half divided by 2, that's a quarter. Now, f of a quarter is what? Put a quarter in here, so for x. So 4 times the sine of a half, because 2 times a quarter give you a half. So it's 4 times a sine the sine of a half plus a quarter cube, so 0.25 cube minus 3. We put that in our calculator, we get negative 1.06, which is less than 0. Since this is less than 0 and half is greater than 0, therefore the root lies on a quarter and a half. Now since the root lies on a quarter and a half, therefore, remember I said only 3 bisection we should do. So the root is a quarter plus a half divided by 2. Quarter plus a half divided by 2. Quarter plus a half. 0.25 plus 0.5 divided by 2. That's 3 over 8. That's an approximation of the root. 0.38. That's it. How much marks are given for this? 0.3. 0.375, they're giving away another 6 marks. So this is 6 marks for this question. So I guess 2 marks for each bisection. Nice. That's that. Alright, part D. Part D says that we have use the iteration xn plus 1 is equal to the sine of xn plus 2 over 3. And what we are supposed to do is take the first approximation. So take x1 to be equal to 1. And we need to calculate the root of f of x. We need to find the root of f of x be equal to sine x minus 3x plus 2. That's what we need to do. Find the root of sine x minus 3x plus 2. Basically, if you cross multiply and bring it over, you get the function. Now, taking x1 equal 1, what we're going to do is put in 1 now. So, therefore, x, look at this, 1 plus 1 gives you x2. x2 is the sine of x1 plus 2 over 3. But x1 is 1. So this is just the sine of 1 plus 2 over 3. You put that in a calculator. Keep the calculator in radians. So sine 1 plus 2 over 3 is 0.947. 0.947. That's x2. Alright? So since 0.947 is x2, we can go ahead now and find x3. So x3 is now the sine of, when this is now, when you put n as 2, 2 plus 1 is 3, this is now the sine of x2 plus 2 over 3. Now look at this. x2, remember, is 0.947, so we need the sine of 0.947 plus 2 over 3. Put that in a calculator, the sine of 0.947 plus 2 divided by 3, I get 0.937. So I get 0.937. So now x4 is equal to the sine of x3 plus 2 over 3. And I put that in now, the sine of 0.937 plus 2 divided by 3. And I get the sine of 0.937 plus 2 over 3, I get 0.935. I get 0.935, and so x5, now you're probably wondering, when am I going to stop? I'm going to stop when I see that I'll get back the same thing. I want the same 3 decimal places. That's when I'm going to stop. So the sine of x5 is going to be the sine of x4 plus 2 divided by 3, which is the sine of that right there, plus 2 divided by 3, and I get back the same thing. Sine of 0.937 plus 2 over 3, and I get 0.935, and so therefore the root is 0.94 to 2 decimal place. That's what I got for the root, 0.94. So if you round that off to 2 decimal place, 0.935, round off to 2 decimal place, that is 0.94. So that's the root of f of x. So the root is 0.94, correct to 2 decimal place. And that's 5 marks. This question is 5 marks. So hope everybody did well on that question. Alright? Stay tuned, we'll finish module 2. Next is module 3. With that being said, I'm out.